So in 9.1, we want to look at what's called correlation. So correlation, we're actually doing plotting points on an X and Y axis, and we're looking at these ordered pairs, and we're creating what's called a scatter plot. So let's start with looking at our data. So constructing a scatter plot, and we're going to use technology here. So Old Faithful, located in Yellowstone National Park, is one of the world's most famous geysers. The durations in minutes of several faithfuls eruptions and the times in minutes until the next eruption are shown in the table. So use the table to display the data in the scatter plot. So describe the type of correlation. So notice how we have to go to the stat button. We go to edit, and L1 is going to be our durations, how long the geyser lasted, how long it erupted for. And then the Y's will be L2. That'll be how long it was until the next eruption. So we put this data in to the calculator. So what we'll do is construct a scatter plot. So this is where the stat plot button comes in. Right above the y equals, they have the stat plot button. So at the second and hit y equals, we get these menus for stat plots. So all of mine are turned off at this time. So I'm going to hit enter on plot 1. And I want to turn mine on. And then I have to choose the type. The scatter plot is the one that has just a bunch of little points here. So type is this first one. So that's what we want here. We've done, this is like the line graph, and then this is the histogram and the box and whiskers types of stuff that we've done earlier. So notice that our X list was L1, our Y list was L2, so that all looks good. So if we go down here, I think that all looks good. So we can quit that. So to actually graph it, what I do is I hit zoom, and number 9 will actually fix the window for us. So number 9 will adjust the window, and it'll create the scatter plot for us. Now, the type of relationship we're looking for is we're trying to look at, see if it's actually has any kind of linear relationship. So what we're kind of looking at is as the duration gets longer, how does it take it longer to erupt again? So it looks like as the eruptions last longer, it looks like it takes longer for the next eruption. So we're kind of seeing that as well. If it didn't erupt very long, then it didn't take very long for the next eruption. But if it lasted for a really long time, then it took a lot longer till the next eruption. So there looks like there's a strong correlation. So as the duration increases, we also recognize that the time increases. So we consider this as a strong, what looks like a positive correlation, if you will, at this time. Now, to determine how strong it is, this is where this R value comes in. So this correlation R, there's actually a formula for it. We're not going to get into the formula at this time. We're actually just, because there's a lot of math to do here if we did it by hand, we actually could do the R value on the calculator. So where this happens at is if we go to the stat button, if we go to calculate, we're doing what's called linear regression, number 4. This linear regression AXL speed. If we hit enter there, notice that the X list is L1, Y list is L2. That looks all good. If we go to calculate, so our I value is supposed to appear here. So my calculator does not show it at this time. So we have some stuff to do on our calculator still. So to make this appear on our calculator, there's what's called turning the diagnostics on. So where that happens at is under our catalog. So above 0 is this catalog. So to get to the catalog, I have to hit the second button and hit the 0 button, and it gives me my catalog. To get to, notice how it's in alphabetical order, I want to get to the D's. To take a shortcut, notice how there's this green D. So hit the Alpha button and hit this X to -1, it'll activate this D. But it seems like I have to do this twice. Alpha, hit the green D again, it'll take me to the D's. So if I scroll through the D's, what I'm looking for is diagnostic on. So that looks like that one's right there, diagnostic on. If I enter diagnostic on, I have to hit enter again until I see this word done. So once I've turned this diagnostic on, that R value should now be turned on. So if I go back to stat, go back to calculate, go back to this number 4, linear regression, go down to calculate, it should now give me this R value at this point, 97. I think we went around to 3 decimal places, so 9789. So that would be our R value. So what we kind of pick up on is if the R value is close to 1 or close to -1, it's considered a pretty good correlation. So let me pause the video for a second here. So if I always want to describe the type of correlation here, we would consider this a positive linear correlation. So if I go back to the graph, what we kind of pick up on as the duration increases, notice that the time for it to erupt again also increases. So we have this positive correlation. So in other words, if we talk about a line, the slope of the line would actually have a positive slope here. So it's described as a positive linear correlation. So also what we pick up on is this R value for our sample. Like, so we just did 24 things here. So this is our sample correlation coefficient. So this R value is our sample correlation coefficient. Notice that when we did that using our stat calculate, we got this linear regression of 0.978, 0.9789. So notice how that's our sample correlation. It's called a correlation coefficient. So what we pick up on is this sample correlation coefficient. It's like the slope of a line, but what we want it to be is we want this R value to be between -1 and 1. And the closer to -1 or 1, the stronger it is. So we have that kind of going on here. So when we talk about correlations, as far as R values go, if R is equal to 1, that's considered a perfect positive linear correlation. A strong positive, notice how if it's close to 1, so 0.81 is considered close to 1, that's considered a strong positive. Notice that a weak positive means it's more like closer to 0, if you will. So if it's kind of more scattered looking, that's considered a weak positive there. Notice how if it's going down, this is considered a perfect negative correlation. So if R equals -1, that's perfect. Notice if it's kind of scattered going down, that's a strong negative correlation. So notice how R was a -0.92. That's a strong negative correlation. So it's almost like a negative slope, if you will. And notice that if it's kind of scattered about, notice how R is like 0.04. Notice how, again, if it's closer to 0, notice how this is actually considered basically no correlation. It doesn't look linear at all. So we have that kind of going on here. Another thing to talk about is this using a table to test the population correlation coefficient. This Greek symbol here is called rho. We'll talk about that next here.